class. This video is going to help with 2.3 in statistics, and these are really graphs. The title is Graphs That Enlighten and Graphs That Deceive, but really we're covering graphs today. All right, so the first kind of graph that we're going to cover is a dot plot. So a dot plot uses quantitative data. Each data value is a point or a dot above a number line. So every single data point has its own dot, and you should be able to see the original data from a dot plot. Should, as long as it's labeled well. So the features are, you can see the distribution of the data. It displays it. So we can look for that bell shape. And also you can find like outliers by your distribution and just kind of information about the data. It is possible to see all of your original, and I took some data here of ages of students in class. I drew a number line and then I go through. On 17, there needs one dot. On 18, there's one dot. Oh, another 18, so I put another one above. And you try to make them even so you can see all the ones that have one, really easy. All the ones that have one are in a line. All the ones that have two are in a line, and so forth. So there's a dot plot, and you can do this in Statcrunch, which I will show you in a minute. So let's go to the next one. The next one is a stem and leaf plot. Stem and leaf plot. This one calls it a stem plot, and so either name is perfectly fine. This one also uses quantitative data, numbers, right? And it separates your numbers into what we call stems and leaves. Typically, stems are your tens, so 10s, 20s, 30s, 40s, 50s, right? And your leaves are your ones. But your tens could also be your hundreds, or, I mean, just depends on your data. You could be also given data in this form right here, just looking at that. And you need to know this 7 represents 17, 18, 19, and so forth. You can easily see the distribution, and that goes to our features. So you can see there's lots more people in their teens or tens, right, than 20s, 30s, or 40s. You can also get your original data back, and it's in order. Those are the 3 things about that graph. The next one is a time series graph. It shows quantitative data that's representing time. So it's a trend over time. We aren't making these. You can't make these in Statcrunch. Maybe you can make them in Statcrunch. Can in Excel. So I know for sure you can do this in Excel. But basically, like in 1985, there were so many deaths of law enforcement officers and so forth. Man, look, there was a big spike, and it looks like 2002, maybe, and so forth. I don't know if this data is real, but there you go. So you should know the name of that, and you should be able to read the data off of that graph. The next one's a bar graph. A bar graph is categorical data, and we call that quantitative. So each bar shows frequency for a category. So very different than a histogram. Each bar has its name. It's a name, not a number, and it goes up to something. So a lot of times people will give me a bar graph when I ask for a histogram. No, but bar graph is for categoric data. Okay, so let me bounce over here and show you an example of stolen boats. So here is a bar graph. So you'll see a label for each bar, and it goes up to our frequency. So categorical data. How many sailboats were stolen? Oh, looks like about 100. How many fishing boats were stolen? A little over 200. It's 250 because there's my actual data, but and so forth. Okay, if I want to take that bar graph and put it in order from highest to lowest, it has its own name, and it's a Perito Chart. Parto. Maybe I should have listened to whoever says that. I don't remember. So Perito chart is a bar graph with the bars in descending order. So it starts with the highest. And why would we want to do that? Is because we can easily compare the categories when they go straight down and be like, oh, there's the highest, there's the lowest, versus trying to read it and see. So it is just an organized bar graph. Okay, so here is my two. I think I can go like this a little. Back, back, back. There you go. Yeah, maybe. Almost see them all together. There we go. So those are similar. All right. You can make both of those on Statcrunch as well. Another chart here. What about our pie charts? Pie charts by hand, so time consuming. In Statcrunch, way easier. So pie charts are categories also for data, and each size of the slice is proportional to the count. So here are the fishing data. There were 250 fishing boats stolen. Okay, and there were 2,721 total boats in this survey. And so if we divide those, we get the percent that were fishing. I just had a huge sound in my headset. I'm not sure what that sound was. Okay, so we divide those and we get our 9%. Okay, and 9% of 360 is 33 degrees. So guess what degrees is right here? 33. But you don't have to calculate those by hand, but you should have an idea. They are categories. We have categories. Sometimes we see how you spend your day in a pie chart, things like that. Okay, and we're definitely doing those on technology. So frequency polygon, a frequency polygon, we can't do this in Statcrunch, and I think you just have a couple examples already drawn. But what they do is it is quantitative data because it's a histogram. And this is our McDonald's data we've seen a couple times. And basically, they take a dot on the top of each bar and you connect them. Okay, so it's a frequency polygon, is similar to a histogram, but it uses lines to connect them. I don't know what this can use. I had a thought and I didn't finish it, so just ignore that. Okay. Oh, I know, can use Statcrunch, and then I realized you can't. I bet you $5, that's what that was gonna say. All right, so let's bounce. These are the type of graphs, let me pause for a second, that you can make on Statcrunch. I'm gonna go ahead and open Statcrunch. And go to Statcrunch. And we need to put in quantitative and qualitative data. I'm going to check something. Just don't mind me for just a second. Okay. So we're going to put in quantitative and qualitative data. So we had those ages of people. So let's put those in. And we had 17, 18, 18, 19, 19, 20, 19, 19, 31, 22, 23, 25, 31, and 42. Okay, and then I'm going to put in the boat information as well. So this was a sailboat, a fishing boat, a motorboat, a jet boat, an inboard boat, and then I'm going to have 100, 250, 845, 1345 or 25. It doesn't really matter. And 201. Okay, so where's my list of charts we just went over? Let's look at the dot plot. So what kind of data does a dot plot have? Category or quantitative? Quantitative. So I'm going to go to graph and I'm going to go to dot plot and I want my quantitative data. Notice it doesn't even give me this one because it's words. It's only saying, do you want it of this numbers or these numbers? And I think the rest is fine. Ta-da! If you don't like the way this looks, you can go back into edit and point size. Let's see what that does. 10. Oh, no, we don't like that. That makes our display like really big. Let's do 1 tiny dots. Group by each limb, group by, yeah, compute. There we go. We can also show the mean and the median on there. That's kind of interesting. Ta-da. There you go. So you can edit. Next graph. Oops, I didn't mean to bonk that. Stem and leaf plot. What kind do I want? Do I want category or quantitative? I want quantitative again. So that's this one. Compute. Ta-da. So all of my ones, my 20s, my 30s, my 40s. So again, that represents 17, 18, 19. So there's our stem and leaf plot. Our bar graph, what do we want for our data? It's with summary. If I had my data, category data, it would list words. It would say sail, 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 fishing boat, fishing boat, fishing boat, fishing boat, fishing boat, and it would be 100 and 250 of them. So we definitely have a summary. And the categories are in variable 2, and the counts are in variable 3, and compute. Oh, I know what it is. My headset is running out of battery. I'm going to unplug it. Okay, continue recording. I figured it out. Hold on. Your audio, I'm going to go to so internal speakers. Okay, so then from there, I'm like, oh, I figured it out. What is this noise in my ears? You probably couldn't even hear it. So from there, we have our bars, and we can see each one goes up to a frequency. What if I want the what if I want them in order? I can go back to edit, and that is here. So you want your count to be either ascending or descending. And that specific graph said it wants it descending, so highest first. So you bring the most attention to the type of boat that's stolen the most. It's first, it's the jet skis. Okay, so that's the different type of bar graphs there, and the Perito or Perit. I'm gonna have to look that up. Perito. Okay, pie chart. So what kind of data we would like our category data? So that is our categories are in variable 2, and the counts are in 3, and that should be pretty enough. And ta-da! There's our pie chart. And scatter plots are really important too, but they're our whole next section, so we're good there. The other thing that we want to probably look at is our deceptive graphs. So as I open this, what kind of graphs are deceptive? They're going to be ones whose their axis doesn't start at 0, or they have a picture on them. They're usually deceptive if they have a picture. So let me go ahead and do a little. I really wanted some COVID data, and I struggled. I looked for like an hour, and I was like, this is a waste of time. All right, so here's one from the book, and this and this and this. These are all the exact same data. Look at what I did. I broke this up, and I separated these by very little, right? So it looked like it was a huge, rapid increase. Same data looks like slow increase. There's the data in a chart. Can I make you see something and believe what I want? Oh, it's easy. All right, take a second. Look at this one. You can pause my video. You should notice that the big one looks like 3 times as big as the small one, but is it? Is this square footage 3 times? No, it's not even double. But man, by that graph, it looks like it. Now look at this one. All right, so look, this is 35 and this is 39. And man, it looks like it is 5 times bigger. It's not. Here's one that is increase in federal welfare. First of all, we increase population, so they don't even include that. But if you look, you don't start at 0. Remember, that's what we look for. And you like made it look more spread out we start at 94 million and we end at 100 and looks like this one's at 106 million. Like, yeah, millions of more people, but really there's more people. So a little bit misleading. The itch relief one, that's 1 minute versus 60 minutes. All right. And then I don't know. I just didn't like this one. It was weird and it wasn't very informative. Last one, tuition and bachelor's degrees. So first of all, again, we started not zero. So then we can kind of scale this any way we want to make it look the way we want. And it looks like tuition is just skyrocketing and you're just not making the money. I don't know. I would really like to know a lot of things about this graph, but I'm basically noticing this. Yeah. All right. Deceptive graphs. Be careful. That's pretty much all I have for this one, this section. All right. Catch you later.